Everybody, hope you're doing well today. Today we're going to be looking at graphing using the intercepts. So last class we looked at graphing using slope-intercept form. Now we're going to look at it how to graph a second way. So some quick review. The y-intercept is where the line or where the graph or where your equation crosses the y-axis, and the value of x at the y-intercept is 0. So if we look here on this problem, again the y-axis is the vertical one here. This is our y-axis. So where our line crosses through the y-axis is right there at 5. And as you can see on the x-axis, it is at 0 on the x-axis. So the y-intercept on this problem would be at 0, 5. Or you could say b equals 5 as well. Remember from last lesson, b represents the y-intercept. So that is where the y-intercept would be on this graph. A little bit of new vocabulary is the x-intercept. X-intercept is basically the same thing as the y-intercept, except for it's where the line crosses the x-axis. And the value of y at the x-intercept is 0. So these are basically the same things, just flipped where their spots are at. And so if we look at this one, we're looking for where the line crosses through the x-axis, which we can see is right here, at x is -6. So the x-intercept would be at -6, 0. So again, the value of y is 0 at the x-intercept, and vice versa, the value of x is 0 at the y-intercept. That's going to be key for when we start graphing, finding the intercepts. So our learning targets are, I can find the intercepts of a linear equation, and I can graph a linear equation using the intercepts. So we have an equation over here. We have 2x plus 3y equals 6, and we are going to use the intercepts to graph this. Now, we're not actually going to graph it yet. We're just going to work on finding the intercepts, but we will work on graphing them here in a little bit. So got some instructions here for you. To find the x-intercept, you plug in 0 for y and solve for x. And to find the y-intercept, you plug in 0 for x and solve for y. So it'll be the same thing, just different ways. So finding the x-intercept, we have 2x plus 3 multiplied by 0 equals 6. Because again, we're going to plug in 0 for our y value. Now, 3 times 0 is 0, and 2x plus 0 is just 2x. So those are going to cancel each other out, leaving 2x equals 6. And we can divide by 2 on both sides, and x is going to equal 3. So the x-intercept for this problem would be at 3, 0. To find the y-intercept, we're going to do the same thing, except for now our 0 is going to be in the x spot. So it's going to be 2 times 0 plus 3y equals 6. Well, 2 times 0 is 0. 0 plus 3y is just 3y. So those are just going to essentially cancel out, go away, leaving us with 3y equals 6. Divide by 3 on both sides, and y equals 2. So the y-intercept here is 0, 2. Excuse me. So this is how you can use, this is how you could find the x and y-intercept from an equation. Let's try it again. And actually, I'm going to have you go ahead and try this one on your own. Pause the video and see if you can't find the x and y-intercept from here. Alrighty, so what you should have done is plug in 0 for our x to find the y-intercept. And you should plug in 0 for y to find the x-intercept. Those would be the two equations we use here. Now, 4 times 0 is 0. 0 minus 3y is going to be a -3y. Still going to equal 12. And we'll divide by -3 on both sides to isolate the variable, leaving y equals -4. So our y-intercept would be at -4 here. On the other one, 4x minus 3 times 0. Well, 3 times 0 is 0. So 4x minus 0 is going to get you 4x. Equals 12, and divide by 4 on both sides to get x equals 3. So here are our intercepts for this one. Alrighty, now let's go ahead and do the same thing, but we're going to actually graph it as well. So let's start by finding the intercepts. Now, one thing if you've noticed, when you go to do these problems, essentially what happens is when you find the y-intercept, just ignore the x. And when you find the x-intercept, just ignore the y. So you can show me this initial step if you want, this step right here of plugging the 0 back in. But hopefully we've noticed, realistically, you end up with this each time. You just end up with the term with whichever intercept you're looking for is the only thing that's remaining. So that's how I'm going to start doing the problems now. I'm going to find the x-intercept, which means I'm going to ignore the term with the y on it. So if we plugged in 0 for y, the 7 times 0 would go away. It'd be 0 and it'd go away. So now I'm going to go ahead and divide by 3.5 on both sides. And x is going to equal 4. Same thing for the y-intercept. If you plugged in 0 for x, it would essentially disappear. And so we would be left with 7y equals 14. So we divide by 7 on both sides. Y is going to equal 2. And now we can graph these. These are two separate ordered pairs. Frequently what people have done is they take the 4 and the 2 and they graph it as an ordered pair, 4, 2. That is not true. It is two separate ordered pairs. We have the 4, 0 ordered pair, and we have the 0, 2 ordered pair. So we need to graph them separately on their own. So we had, like we said, 4, 0. So write 4, then plot the point. And 0, 2. So we would go up 2 and plot the point. Make sure that you do connect it, extending all the way through the graph, and putting arrows on both sides to represent that the line is stretching on forever. And this is how you graph using the intercepts. Go ahead and pause the video and try this last one on your own. Alrighty, so we would have had 7x equals 28, which means divide by 7 on both sides, and x is going to equal 4. We'll have a negative 4y equals 28, divide by negative 4 on both sides, and the y-intercept is going to be at negative 7. So 4 and negative 7 here. So 4, 0 and negative 7, which gives us this equation in this line. If you guys have any questions on the notes from today, please feel free to reach out and let me know. I hope you guys have a great day.